So in this video, we are going to talk about convexity. This is the last topic we want to discuss, and then we will go to the next module. So actually, the convexity going to be used a lot in the next module where we discuss immunization. So really, the convexity is kind of in this module, we just kind of introduce the concept, but then we use it as part of application in immunization. So we have learned how duration can be used to approximate the new price. And so if you remember, when we take the Taylor series expansion, if I go over here, you can see here we have the Taylor series expand around I naught. And then we remove the anything above the first derivative term, and then we get this nice approximation. So that one we can connect to the duration, and we can write it like this. So you can see right away, you can use duration to calculate the price or price change if you want the difference. Now, one thing you can notice, since we are removing this, okay, so since we are removing the higher derivative terms, we are really our approximate price is not going to be the real price. So it's always going to be the under price. Okay, because you can see in here, if I write PI, this is approximated, then that's going to be always less than the real price, because we remove the higher derivative terms. Okay. So this would be the so assuming like I minus I naught is positive. So assuming that, you can see that the real price is going to be higher than the approximate price. So when we come back to here, we have learned how duration can be used to approximate the new price if yield change. However, the approximation will always underestimate the actual price at the new yield. If the yield change is small, then approximation would be satisfactory. However, further we move from the initial yield, the worse the approximation. The reason, if you look at this, it's going to be look like what? So here is the price I naught. We are really using this tangent line. Okay. So when I go to the some rate I, my approximation would be somewhere here. When I go to the new I in this side, my approximation would be somewhere here. So it's always going to be underestimate the real price or real price change if you want the difference. So how we can avoid that? The problem actually is because of the convexity. Okay, so you can see the curve is convex. So one thing we can do, we can add the second derivative term. Okay, so that's why we have this new term or new definition, convexity. So again, you have two type, modified convexity and Macaulay convexity. A modified convexity is defined using this formula: second derivative divided by the price. Okay, so second derivative price function divided by the price itself. Remember how you calculate the modified duration? That's negative P prime I over Pi. So there's a negative sign, but for second derivative, you don't have negative sign. Okay. So if you expand the second derivative, it's going to be look like this. Okay. So what's the price function? It is sigma AK. AK is the money coming at time K. So you have 0, 1, 2, 3, so forth K. This is AK. So AK time 1 plus I to the negative TK. Okay. So that's the price function, and then you can take the first derivative. That's going to make it a negative AKTK time 1 plus I to the negative TK plus 1. Then you have the second derivative. So you will see it's going to be AK, TK plus 1, these two terms, then 1 plus I to the negative TK plus 2, and then divide by the price. So Macaulay duration is defined using this one. So remember how the modified Macaulay duration is defined? D Macaulay. It's basically sigma TK CK. Or in this case, we can use AK because we are using AK 1 plus I to the negative TK. So now when it comes to the Macaulay convexity, is TK square. So, Macaulay convexity, TK square, AK 1 plus I to the negative TK, and then divide by the price. Okay, so both of us. So then you can show that this is basically then you can, using this one, you can show that modified convexity is Macaulay convexity plus Macaulay duration divided by 1 plus I squared. You can find the proof in SO exam FM post note. So that's gave you basically the definition. So every time, if you want to go to the fundamental principle, these are the definitions. So you can always use that. Now, these are not easy to calculate when you manually calculation is maybe not that easy. So you can use Excel functions and the other things to calculate. So now we can use the modified duration to change, calculate price change. So earlier we saw that delta P price change is basically negative D mod Pi delta I. So remember we had this nice, I mean, Pi is Pi naught plus P prime I naught, I minus I naught over 1 factorial, then plus second P prime I naught, I minus I naught square over 2 factorial. So with this is the second derivative. So then we know the modified duration is basically negative P prime I over Pi. So in this case, actually, we can so we can replace Pi naught. So so we can multiply by that and substitute there. So you can see the price change delta P is going to be you can see the mod the I naught I minus I naught. So this would be the delta P. So that's what you have in here, and then this would be delta I. So now you can expand that formula to the second derivative. So in here up we have the modified duration is defined that way. So I can say second derivative let me go back and show you. So formula here. So we are basically cutting off from this point to onward. So we are only using these terms. So I can come back here. So here you can see that so if I use the definition of modified convexity, so I can cross multiply. So I get C mod P naught is equal to second derivative. So I can replace this term by this one. 2 factorial is 2, so that's why you have 2 here. So this one now replaced by modified convexity time Pi naught And then this term is delta I square. So that's why you have here delta I square. So basically, you get the price change now more accurate, because this one is only one term. This one is you have two terms. You are using the second derivative too. So it's become more accurate. Observe that convexity measure is always positive for option-free bonds. Thus, percentage price change due to convexity is always positive, regardless whether yield increase or decrease. This approximation called as second order modified approximation to price change. So, so we had the first order modified approximation. This is first order, because we are using only the first derivative. This is second order. So you can see that you can actually build it more and more. You can have third order approximation if you want. But at some point you have to decide, okay, that's good enough for me. And then you can stop there. So here you have so we talk about the modified duration and modified convexity. We are using that for price change. So here you can see Macaulay convexity and then how they are connected. So we have the second order modified, second order Macaulay approximation for the price. So using this formula. Derivation is again in SOA exam paper. I'm not going to go through that. All you need to right now do kind of like a memorize this formula to use in the exam. So this one is in SOA note, giving the second order Macaulay approximation for the price. So one of a key thing about duration and convexity, you need to know which kind of time periods they are using. If it is in modified duration in years, it is basically modified duration in periods divided by number of periods per year. So let's say you have modified duration measured using 6 months. Then you have to divide by 2 to get the modified duration in years. So how do you do the conversion? That's given in here. Okay, so this formula very useful, because sometimes, like let's say you are getting payments every quarter, then your modified duration is going to be in quarters. Then you have divided by 4 to get the modified duration in years. So let's say it's in monthly. Your payments every monthly. So for this cash stream, you calculate modified duration. Then it's actually in month basis. Then you have divide by 12 to get the modified duration in years. The same for the convexity too. So let's do one example, and then the rest is more for Excel functions. And then we are done with this video. Calculate the convexity for zero coupon bonds in periods. So let's try to calculate this. So here is 0. Let's say after n years, it's zero coupon bond. So you get some value. Let's say the rate is I. So the price under rate I is what? C time Vn. Okay, because it's zero coupon, no coupon. Then what's the first derivative? So you can see if I write this one as C time 1 plus I to the negative n. Okay, because we are differentiating respect to I. So now the first derivative is going to be negative n C 1 plus I to the negative n plus 1. So if I calculate the modified duration, that's going to be negative P prime I over Pi. So of course you can see that negative n C 1 plus I to the negative n plus 1 over C time 1 plus I. So modified duration is going to be negative n divided by negative n divided by 1 plus I. So then the second derivative of this one is negative n c n negative prime negative n plus 1, 1 plus I to the negative n plus 2. So if I take the convexity, that's second derivative divided by price. So let me do calculation here. So that's going to end up as n c n plus 1 times 1 plus I to the n plus 2 divide by price, which is c times 1 plus I to the so c to c cancel out. And then you will have n time n plus 1 time 1 plus I to the negative 2 as modified convexity. You can do the calculation like this. When you have zero more than if it is a coupon bond, then this calculation become more complex than this simple calculation. So here you can find a formula to approximate convexity in Excel functions. Okay, so when you have Excel project, you can use this function to get the convexity. It is very useful. So here you can see that the approach of calculating convexity. This is basically modified convexity, but we use this approach. Okay, that's all. And you can find few questions. Actually, there are not many questions, convexity and duration, just standalone because they are basically attached to the immunization problem. So with immunization concept, we can have more practice problem. But right now, you can just do the homework and do few problems from SOA. But when we come back to the immunization, we will do a lot of problems.